everyone, my name is Soumya Singh Chauhan and this is ELP project. The topic is operational amplifier. So, what is an amplifier? An amplifier is an electric device that responds to a small input signal, it may be voltage, current or power, and deliver a larger output signal that contains the essential waveform feature of the input signal. Amplifiers are used to increase the power, current and voltage of a signal, and they are generally used in music equipments, electric device such as television, radio receiver, audio equipments and computer to increase the amplitude of signal. So here we look how MOSFET can be act as amplifier. For a MOSFET to act as an amplifier, it has to fulfill the required condition, that is VGS is greater than VTH and VDS is greater than equal to VGS minus VTH. So, in this biasing condition, MOSFET is biased in saturation region of operation as current ID is now dependent on the input voltage VGS. Therefore, it acts like an voltage controlled current source and the output current is independent of output voltage. So, the MOSFET act as an amplifier here. Amplifiers are classified in several categories. One of them is operational amplifier, abbreviated as op-amps. Is fundamentally a voltage amplifying device designed to be used with external feedback components such as resistor and capacitor between its output and input terminals. These feedback components determine the resulting function or the operation of the amplifier, and by virtue of the different feedback configuration, whether resistive, capacitive or both, the amplifier can perform variety of different operation which give rise the name of operational amplifier. So here as we can see, basically op-amps have three terminals. One is non-inverting, one is inverting and other is output. So why they are called inverting and non-inverting, we can see from the figure, as if we ground the second terminal and so the V output we get is in the phase with the V1. Here V out is amplified but the phase is same. The phase is not changing in the first case, while in the second case, if we ground the first terminal, so we can see that the output voltage is 180 degree. Output, the phase of output voltage is changed by 180 degree. That's why it is called inverting. So that is the reason why V1 is called non-inverting terminal and why V2 is called inverting terminal. And the third terminal is the output terminal, which represent the operational amplifier output port, which can both sink and source either a voltage or a current. In a linear operation amplifier, the output signal is the amplification factor known as amplifier gain A multiplied by the difference of inverting and non-inverting voltages. So as we can see that V out is given by A times V1 minus V2, and here A is what? A is amplifier gain. So the equivalent circuit of op-amp is given as this, where there is a R in between non-terminal input and terminal non-inverting input and the inverting input, and there is a R out which is connected to the output terminal and the voltage source. So what is the need? Why we make differential amplifier? So in several electric appliances we desire to get V out which is independent of V in. That is, we want V out to be K times V in. But for maintaining this, it is not always the condition that V out is equal to K V in. So we have to make this condition. So for this, if V out is greater than K V in, so what we have to do? We have to increase V out, and likewise in all the three conditions. So for this need, we use differential amplifier. So there are several type of differential amplifier. This is one of them, and here we found that the amplification is 1 plus R2 by R1, where R2 is k minus 1 R and R1 is R. Here k is gain factor. So this is one kind of differential amplifier, and the most famous and other kind of differential amplifier is the inverting amplifier. Here in this, what we do is we connect a feedback resistance between the two terminals. That is, a resistor is often inserted between non-inverting input and the ground, reducing the input offset voltage due to different voltage drops due to bias current, and may reduce distortion of some op-amps. A DC blocking capacitor may be inserted in the series with the input resistor when a frequency of response down to DC is not needed and any DC voltage on the input is unwanted. That is the capacitive component of the input impedance. Insert a DC 0 and a low frequency pole that gives the circuit a band pass or high pass characteristic. The potential at the operational amplifier input remains virtually constant, that is near the ground, in the inverting configuration. The constant operating potential typically results in distortion levels that are lower than those attainable with the non-inverting topology. So here is the factor which differentiate this inverting amplifier from the others. And in this inverting amplifier, the V out upon V in, that is amplification, is given as minus R out upon R in. Here the minus sign indicates that the nature is inverting and the input and the output voltage are out of phase by 180 degree. So in the other diagram we have shown one inverting amplifier, and the some uses and advantage of op-amps is this. In the most basic circuit, op-amps are used as voltage amplifier, which can be broadly divided into non-inverting and inverting amplifier. It is used as voltage follower, selective inversion circuit, a current to voltage converter, active rectifier, integrator, a whole wide of filters, and a voltage comparator. It is also used to perform mathematical operations such as adding, subtracting, integration, differentiation, and some other mathematical operations also. So this is it for the video. Thanks for watching.